We're in Chapter 10. We're looking at transistors and transistor circuits. Transistors gained widespread usage in the early 60s, replacing vacuum tubes in electronic circuits. And so over here to the right we see a picture. This was actually the first transistor. It was invented in 1948, and you notice its large bulky size here. It would be miniaturized dramatically over the years, and it was actually invented at Bell Labs. And they replaced the vacuum tube. Prior to the transistor, all electronic circuits were built using large, bulky vacuum tubes, and it severely restricted electronic development just because of the size. And transistors were responsible for making components much smaller, and they led to the information age, actually. Today, the integrated circuit has replaced discrete components like the transistor. Because integrated circuits are designed around discrete components like transistors, it is essential to have an understanding of transistor operation. So the main reason that we're looking at transistors is because transistors are foundational to understanding integrated circuits. Today, we primarily use integrated circuits, which are literally millions of transistors etched onto a piece of silicon. But to understand how these work, you need to have at least a grasp of how this transistor works. Now, before I leave this, I will say that there are many circuits that still utilize transistors, but much of their use now has been integrated into much smaller components. Okay, the diodes discussed earlier are bipolar devices, as their operation depends upon holes and electrons as current carriers. Two additional bipolar devices are the NPN and the PNP, and these are bipolar transistors. Now, we will look at something called a unipolar transistor later in this chapter, but for now we're going to focus on bipolar transistors. Okay, construction. NPN transistors consist of 3 layers of semiconductor material. Okay, 3 layers, and they make up a thin layer of P-type material sandwiched between the regions of N-type material. So here we have the 3 regions here, and this P material is sandwiched in between the 2 pieces of N material, and this is probably shown bigger than it really is. The P material is really quite very thin. 2 p-n junctions are formed as a result, so you have a p-n junction from here to here and another p-n junction from here to here. A lead is attached to each of these 3 regions. So we have a lead attached here, 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 and this makes up the emitter, the base, and the collector. And this is the schematic symbol that you would see in a transistor. Keep note, the arrow is always pointing to the N material, so in this case, since this is N, the base would have to be P, and then we'd have, so that would be an NPN transistor. Okay, let's talk a little bit about the makeup of this. Notice the emitter here. There's a note here that is heavily doped. And so when we talk about heavily doped N material, that means it is doped so that it will have an excess of electrons. So I'll put many dots in here indicating that this is very heavily doped. Now, the P material, notice it is very thin and it is lightly doped. But since it's P material, we'll have a few holes in here, but as P material goes, it is light doped. It has very few carriers inside it. And then we have the collector, and it was moderately doped, so we're going to see that it has electrons, but not nearly as many as we would see in the emitter. And so this is the NPN transistor, and I just emphasize the fact that the base is very thin and it is very lightly doped, and we'll see that becomes crucial in the operation of a transistor later. Okay, PNP transistors, they are complements of NPN transistors, And you'll notice here, instead of NPN, now it's PNP. The schematic symbol remains the same, except that notice the arrow is, again, now it's pointing at the base, since the base is N material, so now we would have this configuration, PNP. It's very important to look at where is the arrow pointing when you look at a transistor to determine what kind that it is. And again, the same relationships exist. The emitter is heavily doped, only this time it would be heavily doped, but since it's P material, it would be heavily doped with holes. The base is lightly doped, so it would have a few electrons, and the collector is lightly doped, so it would have just a few holes. And again, very, very similar relationship. And notice that this is a complement of NPN. In actual usage, you're probably going to see more of the PNP, the NPN. The PNP is going to require a little bit different voltage arrangement. Typically, well, it's just the biasing is different, and most of our focus will be on NPN. Okay, that completes our introduction to transistors. So we looked at PNP, and we looked at NPN, and we emphasized the fact that the emitter is heavily doped, base lightly doped, and the collector moderately doped. And please recall that the arrow will always point at the N material. And okay, that concludes our introduction to the bipolar transistor.